Before you watch this video, keep in mind that this topic was the longest topic thus far in the 4.5 section, so I've split it into 3 different parts. The things that you'll learn in this part will be put on screen now. Enjoy! Binary number systems. This is a big topic, so please grab yourself a drink or a snack if you can, and strap in, prepare. Now let's do an introduction. A string of zeros and ones is known as a binary number. Each individual 0 or 1 is a bit or a binary digit. If your string of zeros and ones is 8 characters long, it is known as an 8-bit string. This will work the same as if it was 16 characters long, it's known as a 16-bit string, because you are using 8 or 16 bits respectively. A binary number could be signed or unsigned, but there's no way to actually work out which, so a computer must be told whether a number is signed or unsigned. In unsigned binary, if that number is unsigned, it can be directly converted to denary by putting place values above each bit and adding up the total of each bit with a 1 below it. So as you can see here, 1011 has the place values 8421 placed above it, and since you have a 1 below 8, 2, and 1, you take those place values and you add them together. 8 plus 2 plus 1 is 11. So 1011 in binary converts to 11 in denary. Let's talk about the range of unsigned binary. Now, the range of numbers that you can represent using unsigned binary depends on the number of bits that you use, the length of your binary number, which I was talking about in the introduction. To calculate the range of numbers that can be represented by a given number of bits, you can use the equation 2 to the power of n, where n is the number of bits used. So I said this in the last video if you watched. If you didn't, no worries. But if you used 8 bits to represent a number, it's 2 to the power of 8. Which is 256 different values you can represent. And if you use 16 bits, it's 2 to the power of 16, which is 65,536 different values you can represent. You will then know that the range of numbers that you can represent using your unsigned binary is 0 to 2 to the power of n minus 1. So for 8 bits, it would be 0 to 255, and for 16 bits, it would be 0 to 65,535. And you can see my first example used written at the bottom of the slide or screen there. We'll also learn about unsigned binary arithmetic, so to understand how to add binary, you need to know the basic rules. 0 plus 0 plus 0 is 0. 0 plus 0 plus 1 is 1. 0 plus 1 plus 1 is 10. And 1 plus 1 plus 1 is 11. So this should give you a basic understanding before things get more complex. The ones are essentially trues or activated signals, while zeros are falses or deactivated signals, or simply nothing. I'm going to give a quick rundown of this. If you want to skip, that's okay. I just might make it a bit more complex for you to understand. But if you add 3 zeros together, that's nothing, so you have loads of zeros. If you have 1 1 in the mix, obviously you get 1, and 2 ones added together comes back to 0. But you need to carry that one over to the left side. You've got to remember lowest values are always on the right, and your higher values are always on the left. So then if you add 1 plus 1 plus 1, you've moved a 1 to the left because you have 2 added together, and then you have an extra 1 so it stays in place. Hopefully that makes more sense to you now if you didn't get it before. Let's demonstrate an addition. So if we put the line here so that you can clearly see the distinction, 1 plus 0 is 1, 1 plus 1 is 10, so you put the 0 here, and you carry the 1 over to the left, remembering that your smaller values are on the right, and your larger values are on the left. 0 plus 1 is 1, added to the another 1 is 10 again, so you put 0 here, and you carry that 1 back over here, 1. And then 1 plus 1 is again 10, carrying another 1 over here, but you add this 1 to get 11, so you put 1 here, there's a 1 carried over here, so this becomes 1, and your output is finally 11001. I said this in the last video, but you'll probably typically benefit from expressing your binary numbers in a whole number of bytes. So if we just convert this to 1 byte, we'll add 3 practically meaningless zeros here, but at least now it's 8 bits long, which forms a byte. You can also do multiplication with binary numbers, and this is simple. It works practically the same as real multiplication. 0 by 0 is 0 because that's nothing. 0 times by 1 is still 0 because you're multiplying by nothing. And 1 times by 1 is 1. So let's demonstrate some multiplication as well. So again, I'll draw the line in for some ease of view. 0 times by 1 is 0. 0 times by 0 is 0. 0 times by 1 is 0. And in real multiplication, you should know that when you move on from this bottom rightmost value to the next one, you put a 0 at the end here because you're going up. Now you know 1 times by 1 is 1, 1 times by 1 is 1, 1 times by 0 is 0, 1 times by 1 is 1. You can see that this is pretty simple. Again, we're going down, so you had 0, extra zeros here, you had 1 here, now you got 2. And I'm just going to fill in the next line because I already know I'm going to do it again, but you could put 3 zeros here. Doing this line, 0 times by all of this is once again 0. And 1 times by all of this gives you 1, 1, 0, 1. Put another line here to add it all up again. And now your binary addition will also kick in. All these zeros make 0, just a 1, just a 1, just a 1. You got 2 ones here, so we put a 0 here, carry the 1 over, just 1, 1, and another 1. So your output for this will be 1, 1, 0, 1, 1, 1, 0. And again, to make it a byte, just a single 0 at the front here. If you're feeling complicated or you feel like you really understand it, when you do something like this, you could actually write it out yourself and understand, oh, it's 0, so I won't put anything. Then we add a 0 here. It's 1, so we do that. Another 0, so we don't do anything. And then another one where I did 1 0 here, 2 zeros, so 3 zeros. 1, 2, 3, and then just do it again. And you have a much more compact and understandable version of your maths here. As you can see, I've got the same result here. Sorry, I don't know why I've put a 0 here. Ignore that. It's a 1, as you can see. I've got the same result. But yeah, only do this if you're feeling confident. Apparently, I was not. I'm not sure how I made that mistake. That was the end of part 1 of this topic. If you want to watch part 2, it should be on screen now, and I hope you enjoy that as well. Thanks for watching. Make sure to like the video if it helped, it really supports me in the channel, and make sure you subscribe to see more content like this if you like it.